Hello, welcome to this video. So this video will be about a conventional question in paper 1 of DSE about division algorithm and factor remainder theorem. So we are given a cubic polynomial px. So we need to find a and b, which is the coefficient of x squared and the coefficient of x respectively. And then when px is divided by a quadratic polynomial, the remainder is x plus 13. So the second sentence. Okay, so that's why in part A. So we have the expanded form of px. This is its expanded form. And then based on the division algorithm, so when it is divided by quadratic polynomial, a cubic polynomial divided by a quadratic polynomial, so the quotient would be a linear polynomial. So cx plus d, and then times the quadratic polynomial, and then plus the remainder polynomial. Okay, so that's why here we can just simply expand the right hand side, and then cx times x squared, so that would be cx cubed. And then we have the x squared term. So in dealing with the x squared term, that would be this. And then we have that. Let's expand it mentally. So that's why, we will have d minus 2c x squared. And similarly, we have the x term. So that will be 3c minus 2d and then plus 1. And then finally, we have d plus 13 for the constant term. I mean 3d plus 13. Okay, so just check the answer before we go on. Otherwise, we cannot figure out a positive answer in part B. Good. So, and then we just try to do the comparing coefficients of the like terms on both sides of the px. So that's why c equals 2. So if c equals 2, then we can also figure out the yellow term, the constant term. Right, so now, we have 3d plus 13 equals negative 20. So that's why negative 3 divided by 3, so that's why d equals negative 11. And then after that, we can then find out a and b. So a equals d minus 2c. With the substitution, negative 11 minus 2 times 2. So that's why a will equals to negative 15. And then we have b equals 3c minus 2d plus 1. With the substitution, so 3 times 2 minus 2 times negative 11, and then plus 1. So 6 plus 28, and then that will be 29. And then in part A, we are asked to find A and B. So find. Done. Part A. B. So now we have polynomial px. So we have A and B. So that's why we just try to plug it using the factor theorem. We try to find P5. A is negative 15. B equals 29. Right? So, and then using the calculator is 0. So that's why x minus 5 is a factor. Okay, so that's part A and B. Alright, so as in part C, so about the solving of the equation px equals 0. Then with part A, so we have the expanded form of px. And then from part B, we know x minus 5 is a factor of this cubic polynomial. And then we just try to make use of the factor, the factor find, to do the long division to factorize the cubic polynomial. So minus 10x squared, so that's why we need minus 5x. And then minus 5 times plus 4 equals negative 20. Then we can have this factorization. And then just x minus 5 equals 0, or 2x squared minus 5x plus 4 equals 0. And then for the quadratic equation, because okay, we want to conclude whether the cubic equation, okay, as a whole, whether it has two irrational roots. So that's why we try to see the delta of the quadratic equation, the component equation. So that would be 5 squared minus b squared minus 4ac, then which is negative 7, less than 0. So that's why you can see the equation 2x squared minus 5x plus 4 equals 0. So this, okay, so does not have any real roots. So if does not have any real roots, that means does not have any irrational roots, or does not have any rational roots. So very important about the real roots. If no real roots, then no irrational roots. Okay, no any contribution here. And then here, since the 5 is not an irrational number, so the whole equation, okay, as a whole, let's conclude. So it has no irrational roots. So that's why the claim is disagreed. That's all for this video. Thank you for watching.